Check it.
Okay, welcome back. Today we're going to be doing section 6.6, which is called the remainder and factor theorem. We're going to start with the remainder theorem. The remainder theorem is something that you might think you don't need because it does something you already know how to do. However, we're still going to learn it and we're going to use it because it actually leads to something later on. So what the remainder theorem does is that it says that if you want to plug a number into a function, okay, like for instance, for example, a here, we want to find f of 3 if f of x is this function here. Well, you learned in pre-algebra how to do that, right? What you do is simply plug in 3 wherever you see an x. So that's a 3, and that's a 3, and that's a 3, and you see what you get. So f of 3, right, is equal to negative 3 times 3 squared plus 5 times 3 plus 4, which is 9 times negative 27 plus 15 plus 4, negative 27 plus 19, and you get negative 8. So this is the way you know how to do this. We're going to learn a way to do it a little bit differently using synthetic division. Okay, so synthetic division can actually let you plug something into a function in a kind of weird way. And this is called the remainder theorem. Now, simply put, if the number you want to plug in, if you take the number you want to plug in and you divide this using synthetic division by this number, the remainder you get will be what you get when you plug that number in. A little weird, but it does work. So check this out. We want to find f of 3, and here's the function f of x. Instead of plugging the 3 into all these, we can just divide by 3. So put the 3 outside, okay, and you don't have to worry about the whole, x minus c, and you have to flip the sign on the c. That doesn't really enter into this because they tell you straight out what your c is. Your c is 3. And let's see, we have all our powers here, so we're not going to have any zeros to plug in. This is just going to be negative 3, 5, and 4. And if you remember how we did synthetic division back in the earlier part of the chapter, you drop the first number, you multiply this times this, you put it here, then you add these. And that's going to be negative 4. 3 times negative 4 is negative 12. And 4 minus 12 is negative 8. And whatever you get here, that's your answer. And that's what I predicted when I did it the long way. Now, you might say this took about the same amount of time as it took me to do the thing up here. And you probably would be right, because for a simple quadratic function like this, plugging in the x twice doesn't take that long. But when you get into bigger and bigger and bigger functions like this fourth power one, it starts to become more of a pain. So synthetic substitution actually works faster. Okay, so anyway, my point is you can check your answer if you want to plug in 3 and check your answer with a calculator when you're doing your homework, not on the test. But for the purposes of our homework tonight and for any quiz I give you, you do need to do it with synthetic division using synthetic substitution, which is called the remainder theorem. Okay, all right, let's just do one more quick one. I mean, it's so simple, it doesn't require us to spend a lot of time on it, but let's just do one more. So this time we want to plug in negative 4 into this function. So put the negative 4 outside and set up your synthetic division. Now remember, with synthetic division, you have to have all the powers, as the same with long division, by the way. So 4, 3, hey, we're missing a second power function, so we need to insert 0x squared in there, okay? Then we have 1 and we have x to the 0 here. So we have 3, negative 2, the 0 we need to insert here, 5, and positive 2. And then you just do your synthetic division. So you drop this 3. This becomes negative 4 times 3 is negative 12. This is negative 14 when you add these. When you multiply 14 times 4, you get 40 plus 16 is 56, both negative. This becomes 0 plus 56, which is going to be 56. Negative 4 times 56, so 200 plus 24, negative 224. You add the 5. Well, actually, it's negative plus positive, so you're subtracting 219. And then negative 219 times 4, which is 438 times 2, which is 876, right? 876 positive. And then when you add the 2 plus the 876 will be 878. And that should be our answer. Okay, now I do have the answer here. Let me check it. Yep, 878. There it is. Okay, so that's, now you could have plugged in a -4 here, a -4 here, a -4 here, and, but -4 to the 4th power, well, it's kind of a big number. It's 256 actually. All right, so that's synthetic substitution, aka the remainder theorem. Now this next example that I'm going to do, the purple ones here, are honors class. So in the Edpuzzle for the academic class, I'm going to chop this out of the video. However, if I forget to do that, or if you're watching this on YouTube, just skip past the purple stuff here, and then meet me further down for the next part, which is for academic again. Okay, so in the honors class, we're going to be doing something a little bit weird with this, which is we're going to, oops, hold on a second. We're going to, still doing that. What's going on there? Okay, make some room. Good. We're going to look for a value that will create a factor here. So here's what I'm talking about. If you remember earlier from synthetic division, that if you got a remainder of 0, that something was a factor. In other words, check this out. Let's say, okay, here they're using x minus 1, so that means c equals 1. If we're dividing this by 1, okay, the term x minus 1, and let's see what all these are here. 4, 3, -4, and then usually here this would be a number, but this time they're giving us the letter k, which is an unknown. We don't know what k is. And they said find the value of k so that this x minus 1 is a factor. Now, if this is a factor of this, the remainder has to be a what? A 0. Okay? So the question here is, if you do the synthetic division, what k would land you with a 0 here? Will give you the 0 you want here. So let's just go ahead and do the synthetic division and see what happens. What you do is you drop the first number as usual. This becomes a 4. This becomes a 7. 1 times 7 is 7. 7 minus 4 is 3. 1 times 3 is 3. Now, when you get here, you'll look at this last column. What's supposed to happen here is this plus this is supposed to equal this. So that creates an equation that you can solve. K plus 3 is supposed to equal 0. Subtract 3 from both sides. K equals -3, and you're done. You just answered that question. So let's try another one. This one's phrased a little more differently. Determine the value of k if the remainder of this division is 3. This is the exact same question. It just looks different, and I'll show you how to set it up. Well, you're now, instead of dividing by x minus 1, written this way, you're dividing by x plus 2, written this way. It's still division by x minus c, so c must be, in this case, x minus c. This is c equals -2. So you're still doing the synthetic division. That hasn't changed anything. Okay, -2 out here. And your powers, 3, 2, 1, they're all here. Good. So this is going to be 1x cubed. But instead of a number, they put the k over here now. Okay? And then you have 1, and then you have 5. But this time, they're telling you the remainder. They're saying the remainder has to be 3. So put the remainder down right here, 3. That's going to be your remainder. Now the question is, what k would make this happen? Just do your synthetic division, and you'll see. Bring down the 1. That's a -2. Now, what's k plus -2? Well, it's just k minus 2, right? You don't know what k is, so you can't plug anything in for it. So k plus -2 is k minus 2. Then multiply this times this, you get -2k. -2 times -2 is +4. Now add 1 plus 2k plus 4. Well, that becomes -2k plus 5, right? Because 1 plus 4 is 5, and the 2k is, the -2k will stay there. And now -2 times that will become -4k minus 10. I'm sorry, +4k minus 10, because -2 and -2k, when you multiply them, -2, -2k becomes +4k, and like your TV, and -2 times -5 is -10. +5, -10. All right, so now, once again, you get to that last column, all right, and it just creates an equation that you have to solve. All kinds of reminders going off today. So it's going to be this plus this has to equal this. So here we go. 5 plus 4k minus 10 has to equal 3. And you can just solve this algebra 1 style. So 5 minus 10, that's going to be negative 5. All right. You can add 5 to both sides to get rid of this negative 5 here. You get 4k equals 8. And divide both sides by 2 and k equals 2. You are finished. Okay, if you're in the academic class, come back. All right, let's go on to the next thing. So that was called the remainder theorem, where the remainder gives us an answer to something. Well, this next part is actually something we've already touched upon in section 6.2. This is called the factor theorem. And the factor theorem simply says that if you have a factor of a polynomial, and you divide the polynomial by that factor, your remainder needs to be a 0. Well, duh, we knew that already, but we're just going to do a little bit of it again. Okay, this kind of like a refresher. And the difference is that now we know how to factor cubes, sum of cubes, difference of cubes, that sort of thing. So we're bringing it back just so you can do a little bit of that. Okay, so we have here a polynomial, third power. We cannot factor it. We don't know how to factor it unless it's a difference or sum of cubes, which it's not. So we're going to divide by this, and then it'll come down to a second power after we do the division, and then we know how to factor second powers. So let's take a look here. They're saying divide, well, is x minus 5 a factor? Well, once again, for synthetic division, you need this to be x minus c, so clearly c is 5, right? So since c is 5, we're going to put a 5 out here. And now we have 1, minus negative 7, positive 7, and 15. All the powers 3, 2, 1, and 0 are all there. So no need to plug in a 0 there. Drop your 1. 5 times 1 is 5. 5 minus 7 is negative 2. That's going to be negative 10. That's going to be negative 3. And 5 times negative 3 is negative 15. And you can see there's your 0 as expected, because we were told, well, actually, no, we weren't told. We were asked, is this a factor? Determine whether this is a factor or not. And then they said, find the remaining factors. So the only way to do that is if this is a factor. So in a way, they kind of told us it was. Okay, so we know now the factorization of this is x minus 5 times something. And that something is what we get when we do the synthetic division. Now remember, if you start with a third power and you do synthetic division, you always come down 1 power. So this is now a second power. So this is 1x squared. I'm not going to write the 1. Minus 2x minus 3. So this is x squared minus 2x minus 3. But you're not done unless this is completely unfactorable. And I think this is factorable, so we're going to have to keep going. So the x minus 5 doesn't change, but now they want us to find the remaining factors. So what are the factors? Well, because there's a 1, meaning no number visible in front of the x squared, we can just use reverse FOIL. Just put down your x's, right? So what are two numbers that multiply? What are two factors of negative 3 that add to give you negative 2? Well, obviously 3 and 1. The 3 would have to be the negative and the 1 would have to be the positive. If you check it, that works, and now you're done. There's your factorization. So we did something like this before. This is not new. Once again, just kind of breezing through it. But once again, since the theme today is remainders of synthetic division, we have two things that we do with the remainders. One of them is that the remainder is actually what you get if you plug a number into a function. And the second one is if the remainder is 0. Okay, and actually this makes a lot of sense, because if you plug in 5 into this function, you will get, let's say this is y equals, and you plug a 5 into all these x's, you will get y equals 0, which means you're getting an x-intercept. And if you're getting an x-intercept, then 5 is a root. And if 5 is a root, then this has to be a factor. So this all ties into what we learned before. But let's not get too crazy here. Let's just go ahead and do one more example. Okay, so we're looking for x minus c to tell us what to divide by. Well, clearly, this is in the right form, just c is 2. So if c is 2, that's 2 right there. And this is x cubed, oops, I'm sorry, coefficients, not the actual terms. So the coefficient here is 1, negative 7, 4, and 12. Drop the 1. Add that, multiply that,
Add these, multiply these, and that gives you a 0. So once again, the 0 tells us that this is a factor of that. Show that this is a factor of this. I just did. So I completed the first task. Then find the remaining factors. Okay, well, so far I know the factors of this, this third power function here, or third power expression here, is x minus 2 times something. And that something happens to be x squared minus 5x minus 6. That I got from synthetic division. But this is still factorable. So one more time. So once again, this is exactly the same question. I should have chosen something a little better, but this is what I had from last year. So anyway, let's see. Two numbers that multiply to give me -6, that add to give me -5 are going to be 3 and 2. No, actually, that's not going to work, because if they're both negative, that'll give me the right middle, but this will be positive. So hold on a second here. Something is off. Maybe a different set of numbers. 6 and 1. 6 and 1. Try that. 6 and 1. This would have to be negative. That would have to be positive. And yeah, that one works. So this -6 times 1 is -6, and -6 plus 1 is -5. Yeah, there you go. And that's it. There we go.
Okay, let's try just one more here. It says here, fully factor this fourth power function here, or fourth power expression here, if you know that x minus 5 is a factor. Now, it's a fourth power thing. We don't know how to factor something like this normally. But if we're given one factor, we can definitely use synthetic division here. So let's divide by x minus c like we're supposed to. That means that c must equal positive 5 here. Put the 5 outside and do our synthetic division. So this is going to be 8. Well, so hold on a second. This is 4 power, third power. There's no second power. So we need to insert a 0x squared in here to make this work. And then minus 27x plus 135. So 8, -40, 0, -27, and 135. So let's do the synthetic division now. Drop the 8. 5 times 8 is positive 40. And this 40 plus this 40 are going to cancel out. So you get a 0. 5 times 0 is still 0. 0 plus 0 is still 0. And 5 times 0 is still 0. Wow, lots of zeros. -27 plus 0 is -27. And 5 times -27 is 100 plus 35, -135, which gives us a 0 remainder, which actually, since you know this is a factor, this had to happen. So what's our factorization so far? This thing equals x minus 5, the factor we were given, plus, well, what's this right here? Well, remember, whatever power you start with, you come down 1 power from there. So this becomes a third power down here. So this is 8x to the third. This would be 0x squared and 0x, but we're not going to write those down. And actually, that's not going to be a plus. Minus 27. So now we have this. We have 8x cubed minus 27. And that's our factorization so far. But if you look closely, this is a difference of cubes, right? And a difference of cubes, if you remember, the formula goes a cubed minus b cubed gives you a minus b times a squared plus ab plus b squared. Okay, so we're going to use this formula to factor this. Now, what's being cubed? Just a little review from last time. What's being cubed here? What's being cubed here? What we're cubing here is 2x. Because 2 times 2 times 2 is 8, and x times x times x is x cubed. What are we cubing here? 3, because 3 times 3 times 3 is 27. So your a is 2x, and your b is 3. Okay? Which means that your factorization is going to be, here's the x minus 5 from before, but you're going to get the 2 sets of parentheses that you see here. It's going to be 2x minus 3. A squared is 2x times itself. So 2x times 2x is 4x squared. Plus AB, which is 2x times 3, which is 6x. And plus b squared, which is 3 squared, which is 9. Now, do you have to factor this last trinomial here? Remember, with a difference or sum of cubes, this last trinomial is always unfactorable. And if you want to prove it to yourself, just take the discriminant, b squared minus 4ac. B squared is 6 squared,
minus 4 times A times C. A is 4 and B is, C is 9. This is going to be 36 minus, and this is going to be 36 times 4, okay, which is 144. So 36 minus 144 is a negative number, and right away that proves that this is, first of all, not factorable. Second of all, only creates imaginary roots. So you're done, and that is it for this problem. Okay, homework is down here. See you at the next video.
Check this.